Hey, welcome back. Chapter 9, Lecture 9.4. I think the second last lecture, actually. So I think we're just going to have 5 lectures in this chapter. You've been reading in this chapter, and you've been feeling, as I've suggested, that humans aren't all that good at rational problem solving. When we have some question come to mind or some solution we're seeking, we're not all that good at really doing the whole detailed, logical, rational analysis. We can do it. And of course, we're using our frontal lobes when we are doing that sort of problem solving, but it doesn't feel natural to us. It feels hard. It feels difficult. It's something we have to learn to do. So that raises the question of, well, if solving problems in the rational way feels unnatural, what's the more natural way? Here we are, problem solving with heuristics. Heuristics. What are heuristics? Well, by the end of this lecture, I hope you have a bit of an answer to that question. It won't solve you, it won't shock you, by the way, to maybe realize that some of the problem solving we're going to talk about now is going to come from the unconscious mind. Again, we have that duality all through this course of the conscious mind versus the unconscious mind. This is always a tricky way to start this, but I like it because it's memorable. And it is actually one of the first studies of human decision making. So, making decisions is a pain in the butt. What the heck? These are talks I often give to judges as part of the National Judicial Institute who have to make decisions all the time, and they're interested in how people come to make certain decisions and to solve certain problems. And it turns out that one of the very first psychological studies that investigated this did it in the context of colonoscopies. Colonoscopies are when they stick that camera up your butt and they do it looking for potential early signs of colon cancer. The good news is it's a relatively painless procedure, and if you catch the cancer early, you can cure it quite easily. But if you don't catch it, then you let it progress, then eventually it can become a very, very serious, in fact, fatal form of cancer. And so doctors want to convince patients to come in and get a colonoscopy. Okay. They don't want to, most patients. Why? Well, because they've talked to other patients who describe the procedure as sometimes embarrassing, but also painful. And so they wanted to understand, what makes somebody end up saying that something is painful. Okay, so they were doing these studies where they had different patients undergoing colonoscopies. And what they did is they asked them during the procedure, using a little dial, patients are, of course, fully conscious during this, using a little dial to indicate how much pain they felt at a given time. And so here's 2 pain profiles. Patient A, now you see the whole procedure only lasted 6 minutes for patient A. And it started okay, but it ended at a kind of painful point. But then it was done, versus patient B here, who the process took 19 minutes, 3 times as long. And, you see all sort of peaks and valleys in pain. But the important thing for this theory we're going to talk about is early on, it wasn't very painful. And by the end, it wasn't very painful. Even though at times it was, quite painful, perhaps more painful than patient A felt. So when you ask these 2 patients, how painful was it? And you kind of think, well, which one is going to report it as more painful? You might think it would be patient B. Patient B certainly experienced a whole lot more pain throughout the procedure, but it turns out it's patient A that ends up saying this was a painful procedure. It's patient A that's complaining the most. And this led to one of the first, I mean, this is really specific to pain, but one of the specific theories about how people kind of experience or remember a painful experience and how they tell other people about it. And it became known as peak end theory. So the idea is that people often remember some experience by the way they felt at the start, the very start, the very peak times, so the sort of best and worst, the lows and whatever, and the end, which is sort of the lasting feeling. And so this end was very important. The reason patient A does not like the procedure is they were not feeling well right at the very end of it. And that is the lasting feeling, right? That's the one they take with them. Whereas patient B, it wasn't very painful by the end. Even though the peak times, were maybe similar with these two and the beginning was very similar, we're seeing here that the end really matters. Okay, so this was the beginning, though, of the scientific study of how do people, like if you ask them a question like how painful was that, this suggests they're not using the real data, right? If they were using the real data, patient B should have described this as far more painful than patient A. They certainly indicated a lot more pain throughout. They're using something else, a sort of rule, and this is a sort of rule. So heuristics are kind of rules. And what this is saying is when people are remembering that experience, they remember how it started, they remember how it ended, and they remember highlights. That's how they remember things. So they don't take all of the data from that experience. They only use certain bits of the data to form their decision about how painful it was. Okay, and so these are the shortcuts people are taking when they're making decisions, and that's what we're going to learn about. In fact, a lot of this was presented in, I do this with judges. I will give a sense, and I'll give you the formal reference to Daniel Kahneman in a moment. But even this analogy, I don't know how well it works with you guys. I think some of you guys know about Star Trek. Star Trek still lives on in various forms, and maybe some of you watch the more recent forms of it. In its earliest form, the very first Star Trek, the two key characters were Captain Kirk and Spock, Lieutenant Spock. Spock was a Vulcan, and he was highly rational. All of his decisions were very logically based. Captain Kirk was a human being, and they sort of intentionally made him a very sort of emotionally centric human being, a very human being. And so he was not always rational in all of his decisions. A lot of his decisions were driven by emotional sorts of forces of various kinds. Now, this is an episode where these two were actually at battle. They're actually typically on the same team. They're working together. But throughout the episode, we are always contrasting, or the writers are always contrasting this sort of logical approach to things through Spock versus the more human approach to things as embodied by Kirk. And so when I talk to judges, I say, all of us in society want you guys to be Spocks. We want you to make decisions based on data, logic, rational analysis, not emotion, right? We want you to be this. But in fact, you are this. You are a human being. And this sort of decision making, this sort of problem solving is not really rational is not really human. It is rational. But being rational in that way is not the typical approach for humans. The humans instead tend to rely on these shortcuts. And so you have to, these heuristics. So you have to, as a judge, be aware of these, because this is, part of you, and it's going to influence you. You cannot just divorce yourself of your humanity. And so, that's just an interesting context where you guys can think about, how important this distinction can be, because we do want our judges to be data-driven and to be logic-driven, but they are human beings. So Daniel Kahneman was the one that first sort of talked about this distinction in his book called Thinking Fast and Thinking Slow. And, when you think of the fast and the slow, again, the fast is kind of like the unconscious mind. the limbic system, the decisions that come from that, which come very quickly. The slow is like the frontal lobes, the conscious mind, the thing that works things out in very rational, strategic ways. And what Daniel Kahneman is saying is both of these are within us. The rational part is hard. The other part's always there. And it's always trying to bias us in certain ways based on these rules we use. And so Daniel Kahneman laid out a bunch of these rules. He talked about these rules that lead to certain biases in how we solve problems. I'm going to give you a taste of a couple of those rules here. And then I'll show you a whole bunch more at the end to give you a sense of just how many there are. And by the way, let me mention really quickly, I really wanted to stick with my slides that I used the last time I taught this chapter because I'm a little late filming all of these. I've been trying to keep up, but it's been a challenge. So I'm worried that some of you may have already watched the previous lectures, in which case I want to stay as close to that as possible. And when I went and opened the PowerPoints for this, they weren't the right PowerPoints. So what I had to do is copy the PowerPoints that are in the actual lecture. So that's why you're seeing some of this YouTube stuff and things on the bottom here. These are copies of my previous PowerPoints. Just thought I'd explain that to you. Okay, so let's talk about a couple of these heuristics and then talk about the bigger set and give you a sense. But the idea is to give you an idea of how these come into play. So we're going to talk about a couple of things, and these are the things that a lot of psychological studies have looked into. These two are kind of related, and so the question is now, what if you ask somebody, how frequent some event is, or what's the probability of some event occurring? We all know as soon as we hear probabilities, we go, ugh, right? Probabilities can freak us out, and we feel like we're not very good at it. But let me give you a few questions. Now, this never works as well as, it never works in this context, a teaching context, like it does in a real experimental context. In a real experimental context, I want you to imagine the following. Somebody may be just going out somewhere with a clipboard, asking people if they can ask them some questions, and they have questions that include a whole bunch of various questions. And in amongst them are a few like this. Let's talk about death. We just say, hey, if you were thinking about what might actually lead to your death, what's more likely to kill you, your dog or your furniture? Okay. And other questions that we might have mixed in somewhere along the way is, what's more likely to kill you, alcohol poisoning or lightning? And maybe somewhere else, what's more likely to kill you, hot tap water or a plane crash? Okay. If I just ask you these things directly, let's start with this one. If I just ask you these things directly, you go, hey, wait a minute, Jordan, this is up to something, a dog or furniture. What's your first thought? What's your immediate thought? Your first quick thought is probably the dog. A dog is much more likely to kill you than furniture. It's your slow thinking that starts saying, wait a minute, what's this dude up to? And then you start to wonder. And in fact, the right answer is furniture. Furniture kills a lot more people. It doesn't attack the people, but it's typically people standing on furniture, trying to adjust something and falling off a chair, falling off whatever, and killing themselves. So it turns out, if you look at the stats, more people die by furniture than by dog. And especially once you hear that once, then you see these other ones and you go, okay, the gig's up. What do you want to say for this one? I would think you would want to say lightning as your first thought. And what's your first thought for this one? For most people, it would be plane crash. Now, again, in both cases, that's wrong. So alcohol poisoning kills far more people every year than lightning does. And hot tap water, scalding tap water, is extremely dangerous, and it kills far more people every year than does plane crashes. Okay. The question is, why might you have thought the other things? Why might you have thought that dog attacks caused more deaths than furniture? And the claim is this. You hear about it. When a dog attacks someone, it's news. When they fall off their chair, it isn't. Okay? When someone gets struck by lightning, it's news. When they die by alcohol poisoning, it isn't. When someone dies in a plane crash, or, God forbid, hundreds of people die in a plane crash, it's news. But when they die of hot tap water, it isn't. And so the claim is this, the brain hears about the dog attacks. It hears about the lightning strikes. It hears about the plane crashes. And because it knows specific stories, then when I ask you this question, you think, well, can I think of anyone who died by hot tap water? No, but I can think of people. I can think of plane crashes. I know that. And so there's this thing called the availability heuristic. What are you able to bring to mind? And if you can bring examples to mind quickly, then you think that's a more probable thing. Okay. Most of us, by the way, if you think of the car that we drive or that our family drives, and if I ask you, what percent of cars are that car? What percent of cars on the road are that car, whatever it is? So for me, it would be like a Ford Escape that we're driving right now. I feel like it's a very high percentage of cars. Why? Because I notice them. They come to mind. I see them all over the place because I drive them. I see other ones. And so when I think, how probable is that car? Wow, it feels really probable. I see it all over the place. I can bring it to mind really quickly. It's the availability heuristic. This is a sort of jokey comic about this. Now, this was what we were worried about before COVID. So there was a brief scare about Ebola many years ago. And people were really worried about dying of Ebola. It turned out that Ebola was killing very few people every year compared to things like obesity, tobacco, alcohol consumption, and yet so this cartoon is, here's a dude that's doing all the wrong things, doing a bunch of things that could probably kill him, but what he's worried about is the thing he's hearing about on the news. Okay, and that thing on the news starts to feel really probable and really dangerous. And so in his mind, that is the threat, and he doesn't see the threats all around him. So we could talk about things like, how did this come into play during the pandemic and with conspiracy theories and with things like that? Well, once you hear some conspiracy theory, now you can sort of see evidence. There's stuff that seems to fit. It comes to mind pretty well, various things. So, I mean, there's just such a range we can talk about. Here's where do we start? Let's start here. Here's an example. How scary is the virus? Well, for some of us early in the course of the virus, it attacked us or our family, and it may have even made some people seriously ill, put them in the hospital, potentially even killed some of our family members. And for those people, when we're talking about the threat of the virus, those examples come to mind, and they find the virus very scary because they have the examples. And so they think if we said, how dangerous is it, they would tend to say very dangerous. For many of us, although we kept hearing it was out there and we kept hearing about hospitalizations and deaths, we didn't know anybody that was in the hospital or, badly sick or whatever. If you don't know anybody, then it's harder to bring that example of scariness to mind. And so if somebody then asks you, how dangerous is the virus, you're likely to think, not very dangerous at all. In fact, you might say, seems just like a flu. I had as many friends sick with the flu, and that's just because those people just didn't have many friends or loved ones or family members that were hit hard in that early stage. But that makes them think of it very different. They think of how dangerous the disease is very different. And if we actually, think, where did a lot of these conspiracy theories start with? A lot of them started with this notion that, there's a bunch of people out there that say this is really dangerous, but we don't think it's very dangerous, and we think they're lying to us. And so, they became so suspicious of the data that we ended up with this divide of people that didn't even believe that the virus was real. That's how powerful the availability heuristic can be. Okay, just to connect these with things that you kind of run into. Here's another thing that I run into now. Again, some of you know I've been working a little bit with the Toronto Police Services, helping them deal with a lot of the anxiety that they face in their jobs. And part of the anxiety they face is that the general public, they feel, don't like them. in general, that they have a prejudicial view, that when they see a cop, they think, oh, there comes another jerk. Why would we think that way? Well, if we think of the news again, how often do we see stories about police officers doing good things for our society? And I can ask you, how often do you think they do good things for our society? I would argue they do good things for us every single day, and that every single cop probably does a bunch of great things for us every single day, none of which makes the news, a lot of which we don't even attend to. Now, I have seen social media posts now highlighting really cool, positive things that police officers are doing, and that's very important, but that's not common. Instead, what's common? Well, those cops that are jerks, those cops that lose control, those cops that for whatever reason do inappropriate things, they are seen. They are in the news. They are videoed while they're doing this, and those videos are spread widely. And so what do we have? Well, if somebody asks you, what % of cops are jerks? What comes to mind? Right? You can immediately bring to mind Availability Heuristic, all of these videos, all of these instances where cops were jerks. And even if that's a very small % of their actual behavior, even if 99.9% of police behavior is positive and good, if that 0.1 is the part that comes to mind, you're going to tend to think, yeah, they're jerks. A lot of them are. Okay, and this is the force that things like police, and this is the force of stereotypes in general, right? False stereotypes. When you're part of some group and your group is portrayed in very negative ways in the public media, that's what people are going to see. That's what's going to come to their mind, and that's how they're going to perceive you. And we think of all sorts of groups that encounter these sorts of biases. We don't often think of our police officers that way. But I'm suggesting to you today, they're in that camp too. That the worst of them, or them at their worst, is often what we see. And that's what we judge them by through the availability heuristic. And we need to be aware of that. We need to understand that we have that bias in place. Cool. And let me just connect that. I mentioned that I give this talk to judges. Again, so that judges start to understand that these biases are there, and they have to be careful that they don't affect their decisions, that the biases don't affect their decisions. Okay. Let's do a different one. That was availability. We're going to now go to something called the representativeness heuristic. And so we do this with this fun little question. I'm going to tell you about Tom. And so just as background, let me say Tom is a university student, and in his university, 60% of the students are in the humanities, 25% are in nursing, 15% are computer science. So that's the sort of breakdown. So now let me tell you about Tom. Tom W. is of high intelligence, although lacking in true creativity. He has a need for order and clarity, and for neat and tidy systems in which every detail finds its appropriate place. His writing is rather dull and mechanical, occasionally enlivened by somewhat corny puns and by flashes of imagination of the sci-fi type. He has a strong drive for competence. He seems to feel little sympathy for other people and does not enjoy interacting with others. Self-centered, he nonetheless has a deep moral sense. Okay, so that's a little bit of information about Tom. And now we ask you this simple question. I told you, there was humanities students, nursing students, computer science students. What do you think the odds are? Which one do you think is most likely? Of these three, which one do you think Tom is? Okay, so I'll let you think about that. Most of you probably said 3, computer science. The better answer is 1. So what we're going to talk about is something called baseline probabilities and the ability of humans to immediately ignore them. I told you that 60% of the students in this university were in the humanities, and only 15% were in computer science. So any random student like Tom, it's 4 times as likely that he's in humanities than in computer science. So if you want to make a good odds bet, a good rational probability bet, you'd bet number 1. the humanities. That's what he most likely is. Why are you drawn to number 3? Something that's a very unlikely according to the prior odds. Well, you're drawn to number 3 because that guy sounds like a computer scientist. Okay, this is what we call representativeness. Once we start to get a little bit of information, our minds very quickly stereotype people. They want to make sense of things. And when we read this, what makes sense is that he's a computer scientist. Computer scientists like sci-fi, dull mechanical writing, not liking other people. These are our stereotypes of a computer scientist sitting in the corner by themselves doing whatever, self-centered, but this deep moral sense. And so the point here is, even though we started here, we will throw this away. This is good data. This is good data to guide our decisions, to give us accurate decisions. And this data says, hey, when in doubt, pick humanities. But then we just forget that. Boof, completely gone because he sounds like a computer scientist. And that's the human side of us, right? Feels like a computer scientist to me. I'm going to forget the odds and I'm going to go with what feels right. Computer science. Okay, let me give you another one that's a little stronger even. What about Linda? Linda's 31 years old, single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice and also participated in anti-nuclear demonstrations. Linda is most likely a bank teller or a bank teller and feminist. Which do you think is right? By now, these are all loaded questions, but yeah. Well, always, the best answer here, the best answer is A. Why? Because A covers B and more. So B is a subset of A. And so there's always more likely that you'll be part of A than to be part of both A and something else, feminist. So let me describe that again. So if we think of, a bank teller, so what probability is it that somebody's a bank teller? Maybe what is the real probability in the world? I don't know, 5% of humans are bank tellers, let's say that. But what are both bank tellers and feminists? Well, now it's a subset of that 5%, right? It's maybe 2% are both bank tellers and feminists. And all of those 2% are also bank tellers, right? If you're a bank teller and a feminist, you're a bank teller. So the best answer is bank teller. That's the one that has the highest odds. And yet we feel like this one is the better answer. Why? Because she sounds like a feminist to us. Single, outspoken, bright, activist, caring about social justice, discrimination, those sorts of notions. Those are the things we connect with a more feminist sort of mindset. And so because that feels right, we will pick a much lower probability one that's a subset of a higher probability one, just because it feels more right. It's our unconscious mind saying, yeah, that's the one that feels good. Rationally, we should pick A, because A subsumes B, or 1 subsumes 2. So if 2 is right, 1 is right as well. And 1 is also right if Linda is not a feminist, but a bank teller. Right? I hope I kind of explained that. It's a little complex. But the idea here is that if we used a very probabilistic mindset, it would be obvious that 1 would always be the smarter one to choose. But we're not using that probabilistic mindset. We're using a much more human gauge of she feels like she fits. She seems representative of that class of person. And therefore, that's why I picked that. People use the representativeness heuristic when they have a client. In this case, this was a sketch of a potential terrorism suspect. When they have a client in court, they will often try to get that client to dress well. And, well, I don't know what happened to dude's hair here. He didn't quite get the sort of slick bank teller hair due. But often, they will have people looking their cleanest and their best in court and trying not to look like a thief or a murderer or a rapist or a terrorist or whatever they're charged with. They want them to look like a good, upstanding citizen so that when people see them, they say, they don't look like a terrorist to me. And that is a very powerful thing. When somebody looks or feels like they belong to a certain category, we're very quick to put them in that category. And so, yeah, when someone's in a courtroom, we try to not have them look like a criminal, not to trigger the representativeness heuristic. Okay. All right, so what did we talk about? We talked about the availability heuristic here, and where's the representativeness heuristic? I don't even see the representativeness heuristic listed on this. But, I mean, you're getting a sense. We've talked before about... I'm looking for confirmation bias, which should be here. Okay, so it would be sort of here. We tend to perceive what we expect to perceive. So that's sort of confirmation bias. We go into things looking for things, and we see what we expect to see. There's a whole bunch of these biases, and that's what Kahneman really did with his research. Is he fleshed out all of these things that affect us that have nothing to do with rational thought, that just come from things like how easy is something to come to mind, or how similar is that person to some stereotype we have. And those biases very much affect the decisions that we make. So if we kind of zoom out in the bigger picture, then again, the idea here is that our frontal lobes are the new kids in town. We're still figuring out how to use them. We use them pretty well, but they're kind of the new kid in town, and they're sitting on top of a very primitive old brain, the limbic system and all that goes with it. That system has had to make decisions long before there was a rational part of us. And it did so based on things like availability heuristics and these things that Kahneman is highlighting. And so what we are now is that old brain with that old way of coming to decisions, but we have this new brain on top of it, the new rational frontal lobe, consciously, the part that can think conscious thoughts and come up with strategies and such. And these two are constantly dancing. And although we associate ourselves with our rational mind, quite often our behavior is a reflection of our unconscious mind. And that's, really what Kahneman through his work was trying to highlight, the way that unconscious mind works. By the way, Kahneman is one of few psychologists to win the Nobel Prize for his research, and it's for this research, showing in a sense how irrational humans are. Cool. By the way, I also included, I think just above this lecture, a little thing I got from the internet kind of showing human irrationality at work as humans are getting together trying to pile on this argument, but the argument's all messed up. So check it out, see what you think there too. Okay, talk to you soon.